this lesson I'm just going to review some language needed with 3D objects, the types of objects they are, things we need to look at. The reason being, we're going to do some stuff with shapes, their nets, volumes, surface areas, all of those, and I'd like to be familiar with the language as we go through. So we'll start at the top here, and what we've got is a basic shape that has a base shape. Now that base, in this case, is a hexagon, and I'm using the base of a hexagon wherever I can through this diagram. So I've got a hexagon on the base, and this shape is 3D, and what happens is, at right angles to this shape and the area, I extend backwards. So it doesn't matter where I go. If I go at right angles to these lines, I will see the same shape. All the way to the top. So this class of shapes, hopefully you can all remember, is a hexagonal prism. And it's got various properties in it. The first one is we can count the corners. Corners all have a special name. In 3D objects we call them vertices. A vertex is a point in three-dimensional space. How many vertices are there? Well, a lot of people let themselves get confused with it. Let's start at the base. We've got 1, 2, 3, 4, 5, 6. Go to the top. We've got 6 more at the top, and there's no extra vertices in between. So the number of vertices is 6 on the base, 6 at the top, which gives me a total of 12 vertices. Now when people look at the nets, this diagram on the right, the flattened out version, they often get confused counting all the connecting ones and these extra points. What you need to remember is look at the top, look at the base. We have to ask, how many edges are there? And again, do them in groups. On the base, we've got 6 edges. At the top, 6 edges going round. And connecting each vertex to its partner, top and bottom, we have an edge. So we have an edge for every vertex in the base. That means there are 6 along the sides. That's 18. Then next to this, we can count how many faces are there. Faces are flat surfaces. Now sometimes it's easier to see it in the net. Sometimes think about what you're doing as you go through. We actually have 2 hexagons. The only reason they're hexagons is because we're using a hexagonal prism. And we've got to count the number of rectangles. And the number of rectangles comes from how many edges are there to make the rectangle. As these fold out, notice each of these edges, these sides, becomes a rectangle on the net. Okay? So we have 4 rectangles. So there are 8 faces. So we're going to use this language in other diagrams. Let's move on. Let's go into a shape that rises to a point. Now a traditional one, you see them in Egypt, is a pyramid. All shapes that do this are traditionally called pyramids, and you describe the bottom. Now there is one special one. Actually, going back, when we come to shapes like this, if it's got an oblong or a square, i.e. a rectangular base, these are collectively called cuboids. So if instead of having a hexagon on the base, we've got a square or a rectangle, rectangles can include the definition of a square and an oblong. So a rectangular prism are called cuboids, and that's a definition you need to know. If all the sides are the same and it fulfills this requirement of all angles being 90 degrees, the special case is a cube, and that's where all edges are the same and all angles are right angle. Are right angles. Okay, they're the special cases though. When we come to pyramids, there's a special type of pyramid. If it has a triangle on a base, the number of faces it has is 4. And there's a weird piece of logic. If we've got a triangular base, tetra in Greek is 4. So, a triangular base pyramid is also called a tetrahedron. Let's go through the same thing with vertices. So vertices, at the base we've got 6, and we've got a single point, the apex. The Americans call it the apex. It's not a bad name. So there are 7. Now there is one thing I'm going to ask you to do is I would like you to try and calculate the relationships. There are relationships for the number of vertices for different classes of objects. Edges. So edges we've got on the base, we've got 6. There is no top, so there's no there. But each vertex on the base has an edge coming from it. So we also have along the sides 6 more, and that gives me a total of 12. And then we got faces. We have one base, which is a hexagon. Then coming from that, we've got to count triangles. Each triangle off the base, we've got each side on the base, we have a triangle. So in this case, we've got 6 triangles. That gives me a total of 7 faces. So, first task for you to do on this, you've got some iMaths, but I would also like a written task. I want you to count and find the relationship for vertices, edges and faces based upon the polygon base. And face based upon the base. So we're linking it to the base. There are different rules if it's a prism or if it's a pyramid. Right, let's move on to some of the shapes. These ones have some weird properties. You should recognise a cylinder, and hopefully you'll be doing some stuff with cylinders in the next lesson. So a cylinder is a circular prism. And if we try the number of vertices, now this dot in the middle is not a vertex, it's not a clear point, there are none. Edges, now there are edges, but we should really stress them. They're not straight, they are curved edges. So the curved edges we've got in the cylinder is where 2 faces meet and you get a smooth line. Now this line is smooth because it's a circle. So we do count them as curved edges. There's 2 of them. There's no definite change. It's not like you've got a curve coming up like that and then a curve there. You would count that as 2 different edges, 2 curved edges. Okay. This is a single smooth curved edge, and there's one at the base. How many faces are there? Now this comes a bit awkward. We have 2 flat faces. and one curved face. That's one. And I wouldn't necessarily combine them. I'd leave them separate, make the distinction between faces that are flat, faces that are curved, edges that are flat, edges that are curved. Some people think we've got edges here. Because this is a curved surface and it's smooth, there is no definite point where things come together and you've got a definite change in direction. This is continuously changing, so there are no edges vertically on this one. Cone is a circular pyramid. How many vertices are there? Well, there is a definite point in the shape on its surface. This one at the bottom is just for creating the circle. But that vertex there is a definite point in space. So there is one vertex. How many edges? Well, there's not one at the top now, but there is one round the base, meeting this conus bit and the flat circle at the bottom. So we've got one edge. We also have faces, one flat. That's the circle. And really I should say what shape it is up here as well. Each time you look at a face, and if you say you've got a flat face, you should be able to say what sort of shape it is. By the way, this is not a face, this is actually what it looks like when a cone gets rolled out over there. And we've got a curved surface, or a curved face. So faces, surface. So the curved surface we've got the one that goes round from this circle and it comes up to a point. That means we actually have a sector of a circle. A bigger circle than the base, but it is a sector of a circle. And that makes one curved one. Finally, one last shape in these groups. We've got the sphere. Vertices, none. There's no definite points on the end here. We can say that's a point and I can see it move. Edges. As I rotate the shape, I can't see any lines that will move around. They stay fixed. If I'm just looking at the surface, no colouring. So there are no edges. Surfaces. Flat. 0. And there is only one. I know there's a circle showing here, but that's just to show that this is circular all the way around because the colouring doesn't quite work. So we've got a curved surface, and it is only one. There's no edges here that I could rotate and see, oh, there's a surface here and a surface there. So there is one single curved surface. Okay, so after this lesson, I'd like you to go and do 2 mind maths exercises, basically reinforcing what we've just done here, using the vocabulary. And then your further task is to take the base shape, if you can calculate it, but for a pyramid, I want to know the number of, and for a prism, how many vertices, how many edges, how many flat surfaces, faces. We're only going to talk about the polyhedra. You do not need to do cone, so not for cones, not for spheres, not for cylinder. Prism, same thing. How many vertices, how many edges, how many faces. And at the end here, so base shape, we need to know how many sides or vertices. I'd like to know how many can you find a relationship. The relationship's a difference between pyramids and prisms. but investigate the relationship, please, on these three-dimensional shapes. You might find it useful to go to Wikipedia and look at these for examples of pyramids and prisms. Wolfram Alpha. Go and have a look at the pictures you can find online. I'm not going to give you the resource. Part of this I would like you to research, as it's such a relatively simple task for everybody. Thank you.